Okay, good morning. Welcome back. Happy Friday. We'll start most classes by just taking a look at the calendar. You have this at the back of the syllabus, but you don't need to take it out every time we look at it together. But today is class number 2. We are going to talk about using equations to solve problems in algebraic expressions. Normally the homework for a Friday would be due on Monday, but again, I know not everybody has their book, so this homework will be due on September 13th, which I think is probably Wednesday. But hopefully if you have your book, you're working through, because otherwise you've got 3 homework assignments that are going to be due all at the same time on Wednesday. Any questions on the calendar? Okay, so a couple of logistical things before we jump in on page 9 in the big packet. So first of all, if you log into Moodle, you will see a list of your courses, and one of those courses is this one. And if you click on this course, you will see this screen right here. And there's lots of resources available on this page. You can mess around a little bit on your own, but there's 2 things I wanted to point out specifically right now. One of them says packets filled in. I've got 2 options here, 096 Monday, Wednesday, Friday. That's you guys. I also teach 096 on Tuesday and Thursday. You don't need to open that PDF. But if you open the Monday, Wednesday, Friday PDF, it looks like this. And this is the big packet, except it's filled in. It's the stuff that I wrote on the smartboard in class on Wednesday. So what this means to you is that you don't need to like frantically copy down everything that I write on the smartboard. I would much rather you pay attention and write down just enough so that you can kind of recreate what happened in class, but you should know that there will always be a full color PDF available to you on Moodle. I'm not gonna make one of these every day. I do it after class on Fridays. It's just a little bit of a process and takes a little bit of time. But if it's like a Monday afternoon and you desperately want the PDF from that day, just send me an email. I will make one for you and send it your way, okay? But otherwise I'll update it every Friday. The other resource I want to point out is the one that says link to playlist of class videos. So if we go into, if you click on that, that link, it brings you to a playlist. At the moment, this is a very lonely playlist with 1 video in it, but it will get updated every time we have a class. And if you click on that 1 video, you will find this, and I will play for you just a small clip of Wednesday's class. Pure magic, I'm telling you. Now that you guys know about this, it's going to blow up on YouTube, right? It's going to be like Justin Bieber, Taylor Swift, and then Ian Math 096. Okay, so what is this good for? All right, so if you're here in class and you just want to see some stuff again, you can go check it out on YouTube. If you are here in class and you have a question, but you're just too shy to ask it, you can maybe figure things out by watching stuff on YouTube. If you miss class, all right, well, there's no substitute for being in class because as you could see, you could hear my voice, but you are not going to hear any of the student voices in class. So you can't replace that experience of being here and having the discussions with each other, but this is as good as I can do for you, okay? So these videos will be here. I'll post them like right after class, usually within 10 minutes, okay? All right, any questions on any of that stuff before we jump back in? Okay, so one other thing, brand new handout. This will be the last, one of the last handouts I give you for a long time, is this practice problems packet. So let's make sure we're clear on how to use it. So it's new on the table, so everybody grab one. All right, so sometimes teachers will give you like a practice test or practice quiz right before each test or each quiz, and I'm doing that too, but I'm doing it all in one shot. So these are like all of the practice tests and practice quiz problems from the whole semester. And all you have to do is be able to read this chart on the first page. So today, you can see on the top left of what's on the board here is lesson number 2. And so if you want to practice problems from lesson number 2, which is what we're about to do, you come to this grid, you look in the left-hand column and you find the number 2. And then in the column right next to it, you see the 4 and the 5. That is telling you in this particular packet, you go to problem number 4 and you do that one, and that will be related to what we're going to do today. And then you go to problem number 5, okay? So don't go in order of the problems in this packet because they're all over the place. So if you want to practice a particular lesson, this is telling you exactly which problems are relevant. Any questions on that? Okay. All right, so I think that we are good. Hopefully we had a chance to read the syllabus. Did anybody have any, not like math questions, but like course related questions, how things run or quizzes and tests and any of that jazz? Okay, well, if you do have questions, you let me know. All right, so for now, we're going to jump in on page 9 in the big packet. So let's all go there. And we'll start with our daily summary. In this lesson, we tackle our first word problems and see a powerful technique for starting word problems. Pick a random number to figure out how to set up your expressions or equations. So that random number business might sound strange. It will make more sense as we do this first problem. So right here is a calculator active problem, which means it's one of the rare problems in the class packet where you're allowed to use your calculator. Again, the default is we're not going to be using calculators for the most part this semester, but I will let you know when we will. So here's an example from your textbook. The price of a 7-day Alaskan cruise, normally $2,752 per person, is reduced by $1.75 per person for large groups traveling together. So if you can get a bunch of your friends to go with you, every one of your friends is going to reduce the ticket price by $1.75 for everybody in your group. How large a group is needed for the price to be $2,500 per person? That is the algebra question that we are going to answer. How large a group do we need to reduce the price all the way down to $2,500 per person? Okay, some of you might be able to think, okay, if I just let X be the number of people in my group, then blah, blah, blah is the expression that is the reduced cost. And if you're one of those lucky few, good for you. That's fantastic. I'm going to give the rest of us a technique that I think is helpful when it might be hard to just jump immediately to the idea of X's. So in the first column here, number of people traveling in large groups, I've got two numbers, 10 and 50, chosen somewhat arbitrarily. I made them up. You'll make them up during the activities. So taking a look, if you have 10 people in your group, how would we calculate the cost per person? What would we do with that 10 to start? So remember, each person is $1.75 off. What would we do with our 10 people? Multiply the 10 by the 175 because every one of these 10 people gets you another $1.75 off. Okay, so that's what we've got written here. 10 discounts of $1.75 means we save 10 times $1.75, which is easy. That's $17.50. Okay, so every person saves $17.50. But that $17.50, that's not what we pay. That's how much the discount is. So how do we calculate how much we pay? Yeah, the total cost, the original cost was $2,752. And now it's going to be discounted by $17.50. I'll highlight that again in yellow. And so then the last step here is to subtract $2,752 minus the $17.50. Turns out that's $2,734.50. And that is the cost per person, okay? We are trying to make it so that the cost per person is $2,500. Do we need more people or fewer people? We need more because this cost is still too high. The more people we get, the more $1.75's off. Okay, so let's play the same game here with a different number, in this case 50, again chosen arbitrarily. So 50 people, I'm trying to simulate this like yellow calculation here, so what do? We do 50 times $1.75. Okay, so this is one of the rare calculator things. I'll try it, but if somebody has an answer, you can let me know. 5, 7, 8. I just failed at that. What am I doing? 25, 7, carry the 3. Is it that? I think that's good. So $87.50 is the amount of the discount. What do I do with that to calculate my per person cost? Okay, so then we do the 2752 and then we subtract this 87.50. And so I'll highlight that in blue. It matches the stuff that's up above in blue. Anybody have this number, or are you guys going to watch me struggle again? Thank you. Okay, so in this case, $2,664.50. Again, the goal for solving this problem is to get the cost all the way down to $2,500. Do we need more or fewer than 50 people? Still need more, but we're getting there, right? Cost went from $2,752 to $2,734. Now we're at $2,664. We're getting there. Okay, so I mean, you could just do like a trial and error, and if you go too far, then come back up. But we want to use algebra. That's what this class is about. So we're going to use algebra, but first a quick detour to define a couple of words. They're underlined here: quantity and unit. Here we go. A quantity is anything that can be counted or measured. And here are a bunch of examples of quantity words. Length is something you can measure. Weight is something you can measure. Area you can measure. Number is something you can count. I can count the number of students in this room. Volume is something we can measure. Time is something we can measure and maybe count. Okay? All of those are called quantity words. Every single quantity word has a corresponding unit attached to it. For example, if I asked you for your weight, don't say a number, but what unit would you tag on to the weight? Pounds, right? Like everybody in this room is thinking, oh, my weight is some number of pounds. That word pounds is a unit. It's something that we all understand. Oh, we know what 1 pound represents, and then we can all compare ourselves to that standard unit, 1 pound. A unit is a fundamental amount of some quantity. Like, for example, length could have a unit of inches, and we just said weight could have a unit of pounds. Area could be measured in square meters. Number, I said number of students, that would be 1 unit. Number of cars in the parking lot, cars could be another unit. Volume could be cubic feet. Time could be hours. All of these quantity words up here, and they have more than one unit word down here. What's another way to measure time, not hours? Minutes. Minutes is a perfectly good unit for time. There's lots of different units for time, okay? Seconds, centuries, lots of them. The reason that I'm stressing this idea of quantity and unit is that when we define our variable in a word problem, let x equal, we got to make sure we include both a quantity word and a unit word. That's the key. So when we come back up here, and we'll just think about the original question, it says, how large a group? That's the question. And in terms of, like word problems, if you're going to define x to be something, you just have to read carefully. I'm going to tell you explicitly what I think x should represent. You just have to find it buried in the words. X should represent the answer to that highlighted thing. How large a group? So we're going to write a small little sentence. Let x equal something. Now, it's really common to have your sentence look like this. Let x equal people. Don't write that. That is not a good definition. We need a quantity word and a unit word. That's at least 2 words that we need, and we only have 1, so we are definitely lacking. When you tell me x equals people, it's not clear to me what it is that you are thinking about in terms of the people. There are lots of things that you can measure in terms of people. Are we talking about x is equal to like the height of the people? No. Are we talking about x is the number of siblings of the people in our group? No. Are we talking x is the hair color of the people? No. There's only one thing that we are thinking about with the people. What is the characteristic of the people that we care about? Yeah, it's they're going on the cruise. And what is it that we're doing with all these people? Like what? It's the amount of people or the number of people. We need a quantity word here. People is a unit. Go ahead and write this. X equal number of people. It's not a big definition. It doesn't take long to write it, but it is worth your time to think carefully. What is it that you are trying to measure? In this case, it's not just people, it's number of people. Okay, so now I'm ready to fill in this blank row in my table. So here we go. X is what we are putting here. It's not 10, it's not 50, it's not a specific number. It is something abstract. It is X. And let's see if we can replicate the stuff that we did for 10 and for 50. So what did we do with 10? Well, we multiplied it by $1.75. What did we do with 50? We multiplied it by $1.75. What should we do with X? We should multiply it by $1.75. So you could write X times 175. But more common, if you have a number multiplied by a letter, you'd put the letter at the end. I'm going to highlight that. What color is that? That is yellow. We're just trying to replicate what we had up above. It's easy with 10. It's easy with 50. Now we're jumping to the more abstract x. Okay, and then going back up here to the 10 calculation, we did 2752 minus the thing in yellow. And then down here with the 50, we did 2752 minus the thing in yellow, yes? So we are doing 2752 minus the thing in yellow. 2752 minus 175x. What color is that? Blue. And that right there is our expression that represents the discounted cost. The rest of this problem is going to be easy. In fact, I'm probably not even going to do it all in front of you. The key is setting that thing up. That is the toughest part of many word problems, setting the thing up. Solving the equation is going to be pretty easy. So here is the moral of the story. If you could just jump from all of the words up above to that thing that we just wrote, the 2752 minus 175x, more power to you. I don't need to see you make up the numbers. But most of us, I think, would struggle to go from the words to this very abstract idea that we've written. And so all we do is we pick a concrete number. What if it's 10 people? What if it's 50 people? I guarantee you it's going to be a lot easier to do the calculations with a number than with an x. But if you do them with the number, it will almost certainly make the x calculation easier. Okay, last piece of this puzzle is to deal with the 2500. We want the price to come down to 2500. And this blue highlighted thing is the price. What do I do with the 2500? Set it equal. That's it. That's it. We'll come down here. So 2752 minus $1.75x equals 2500. And solving the equation is much easier than setting up the equation. In this case, maybe subtract the 2752 from both sides, and then you'll have to divide by that negative 1.75, and you're done. So you can solve this equation later if you're interested. It's not very interesting. The interesting thing for me was setting it up, was getting to that point. If you care, it's 144 people. It's on the next page. Okay, so I'm just going to come down here and read this bold-faced thing on the very next page. If you don't know where to start in a word problem, try picking some specific numbers to see if that gives you any insight, okay? Don't be shy about just making up a number, seeing if that can guide you. All right, so if you go to the very next page, at the top it says activities. So first you're going to reintroduce yourself to the people at your table, write their names down again, and then jump in together on the activities, raise a flag if you get stuck.